So our last section in 1.6 is on different operations we can do with functions. Okay, as I said earlier, how we can combine two functions together. And one of the operations we'll study that's a little more advanced is called composition. Right, so basically the idea is we can take two functions that we already have and we can combine them together using addition, subtraction, multiplication, or division, and we can create a new function. Right, so suppose we had these two functions, okay, f of x and g of x. Okay, one thing we have to be careful when we combine functions is when we talk about domain and range. All right? The values that you are allowed to plug in, that's the domain, and the range are the answers that you get back. Well, you might be able to determine the domain and range of each one of these individually, but once you combine them together and create a new function, you now have to find a new domain and a new range. Okay? Because combining these two functions together can cause different things to happen. Okay, so here's one example of how you could combine them. Right? I could say take f of x and g of x and simply just add them together. Now we've created a new function called x squared plus the square root of x plus 1. Right? That's one way, and a very simple way to just combine two functions together. Okay? Another way we could do it is divide them. Okay? So in that case, if I said to take f of x and divide by g of x, you'd just write that. F of x divided by g of x. Okay, for the moment, I'm not worried about rationalizing the denominator to get the square root out of it. You could multiply top and bottom by the square root of x plus 1. You could get something like this. Right, so if you get an answer like what's on the left, just make sure you understand that what's on the right is the same thing. Now, we have to be careful with the domain and range, especially, let's just take a look at this for a second. What numbers are you allowed to take the square root of and get a real answer, not imaginary? Yep, just positives and one more. 0. So you can take the square root of anything that's not negative, okay, which is 0 and up. All right, so that would be the domain of g of x. Okay? Any number, that's what you want to happen. So what numbers would cause that to happen? I'd have to pick x's that are from what value and up. Yeah, so x would have to go from -1 to infinity. Okay? That's the domain of g of x. But look at what happens here. When you put this in the bottom, okay, you still have that same restriction that you had before. You've got to pick values from -1 to infinity. But by putting it in the denominator, is there anything else I now have to be careful of? Yep. Now it can't equal 0 either. Not because you can't take the square root of 0, but because you can't divide by 0. So now the domain isn't from -1, including -1 to infinity. What's the domain now? All right, you can use 0 and on, but I would also argue you could use -0.5, -0.6. Yeah, from -1, not including it, up to infinity. Okay, so the domain on this one would be something like -1 to infinity. But then on this one, it would be from -1, not including it, to infinity. Okay, so we've got to be careful when we start combining functions. The domains can change a little bit. Notice I didn't pay any attention to the top. That has no effect on the domain. You can square any number you want. Okay, so the only restriction here comes from the fact we don't want to divide by 0, and we don't want to take the square root of a negative. Okay, and there's more examples on page 58. All right, so this is basically writing down what I just explained to you. The domain, when you create a new function, is all of the x's that belong to the domain of both original functions. And if you create a new function that involves division, you have to be careful that you never divide by 0. Okay, so the domain of a new function is all x's that belong to the domain of both original functions. It's almost like you need to pick the smaller domain. If you had one function that had a domain from, say, just to look at it on a number line, let's say it went from 1 to infinity. That was the domain of, say, your f of x. And your g of x went from 3 to infinity. Well, you can only take the x's that are in both. So where's the overlap here? It's everything from 3 and up. Okay? If you have x values that are in the domain of 1, but not the other, you can't use them. It's got to be in both. Okay, questions on that? All right. So let's look at these two functions. Okay, we're going to combine them in different ways. But first, before we combine them, let's just figure out what the domain is of each one of these before we do anything to them. Wait, what's the domain of f of x? What numbers are you allowed to plug into that function? Trevor? And can you tell me how you would write that as an interval?
-3 with the bracket.
Yes, with the bracket.
And then comma infinity with parentheses.
Perfect. Okay, so there's your domain for f of x. How about the domain for g of x? What kind of numbers would you be allowed to use there? Well, Francisco? Okay. Yep, you're allowed to use the number 2 because the square root of 0 is, that's fine. Parentheses. Yep. So there's the domain of f of x and g of x before we do anything to them. Now I want to find the domain of f of x plus g of x. Okay, first that, can you tell me what this function would be? There's not really much simplification we can do, but how would you write f of x plus g of x?
The square root of x plus 3 plus square root of x minus 2.
Yeah, so that's it for the answer to that part of it. And now the domain. What's the domain of this new function? So you have to pick x's that belong to both. So kind of think on a number line. Think of that overlap. Amanda?
Is it bracket 2 to infinity?
Yep. Can only pick numbers from 2 to infinity. Although you could pick something like 0 and it would work in the first part of the function, it would not work in the second. Okay, it has to work in both. Okay, so there's our domain for f of x plus g of x. All right, now f of x divided by g of x. Quinn, what would that look like? Just as a formula.
Square root of x plus 3 over square root of x minus 2.
Yep. Now, we could clean that up a little bit if they wanted the square root out of the denominator. Can somebody tell me what I would multiply top and bottom by to do that? Yeah, go ahead, man. Yep, the square root of x minus 2. So that's square root x plus 3, square root x minus 2, all over x minus 2. And technically, you could multiply these together, because you have two square roots, and you would get the square root of, and then under the root, x squared minus 2x plus 3x minus 6. But I wouldn't multiply them together, because then it's harder to figure out the domain. It's actually better to leave it like this. Okay, what is my domain here? Yeah?
Bracket 3 to infinity parentheses.
All right, 3 to infinity. Well, I would also say that you could use like 2.5.
So would it be 2 parentheses?
Yeah. So we got to think along the lines, we don't have to just stick with integers. We can use decimals. So we can use anything from 2, not including 2 now, up to infinity. Now, why parenthesis on the 2 here, but a bracket up above?
Because you can't have a 0 on the bottom.
Right, because we created a new fraction by division, we have one extra thing we need to check, and that is, did we divide by 0? If you use 2, you would. Okay, so this time it's parenthesis 2 to infinity. Questions on that? All right. So let's, well, example 2 is pretty similar. It's really doing the same kind of thing, except now we have an absolute value to work with. But well, let's do it. All right, so it says graph and find the domain and range of f of x divided by g of x. That's f of x divided by g of x. Can anybody tell me what they think the domain is here? Anyone else have a guess? You're doing great. But anyone else that I haven't heard from yet have a thought? If you're not sure what the domain is, tell me what you think it's not. What are you not allowed to do? Bo, Jeff, do you have any thoughts?
Well, it could be negative because it's in the absolute value.
Sure, you can take the absolute value of negatives. Yep, so negatives are fine. You can divide by a negative number. That's fine.
And then all numbers.
Not quite. It's close, but it's not all numbers. There is one thing you're not allowed to do.
You can't use 0.
You can't use 0. So does anybody remember how you write the domain as an interval? Showing me 0 is not in it. You have to write it in 2 parts. Yeah?
And, parentheses, negative infinity, minus 0, and then like u, well, parentheses again.
Yeah?
U, and then 0, comma, infinity.
Yeah. So this means union. This is like an OR symbol. So you can pick anything from negative infinity to 0, not including 0, or from 0 to infinity. So that's your domain. Now what about your range? What kind of answers are you going to get if you do this calculation? Like, all right, let's plug in the number 5. If you plug 5 in for x, what do you get for y? What do you get?
1.
You get 1. What if you plug in 8? 1. 1,320,472. 1. So it seems like when we plug in any positive number, the only value you get is 1. How about if I plug in negative 3? Get negative 1. How about negative 9? Negative 1. So the range only has 2 values in it. You can get the number 1. And what we'll do is write it like this. 1 and negative 1. We're actually making a list of every number you get because there's only 2. Right, so let's see how that looks. All right, so we've got absolute value of x divided by x. So you either get negative 1 if you plug in a negative value for x, or positive 1 if you plug in a positive value. It's a little bit different graph. Okay, this is not connected. Okay, it's in two separate pieces. Okay, any questions on that? All right. So we started to get into a little bit with range here, and we're going to do more with range as we go. All right, so another way we can combine functions just besides add, subtract, multiply, and divide is called composition. Hey, anybody remember doing composition? It is something you probably did back in Algebra 1. That was a while ago. All right, so I think the easiest way to explain composition is just to show you, okay, an example. Okay, but the idea is when we use composition, we're still creating a new function. We're just doing it in a little bit fancier way than adding, subtracting, multiplying, dividing. All right, so I've got two functions, g of x and f of x. Okay, g of x is the square root of x. F of x is x squared plus 3. And I'm going to find this. Okay, and the way you pronounce what I have written right there is g of f of x. So what we're really going to do is we're going to plug one function into the other. Okay, we're not going to be replacing a variable with a number. We're going to be replacing a variable with an entire expression. All right, so let's do g of f of x. So g of, what is f of x, Taylor?
X squared plus 3.
X squared plus 3. So what this means to do is in function g, everywhere you see a variable, replace it with x squared plus 3. Okay, so function g is the square root of, and now I'm not going to write x, I'm plugging this in for the variable. Okay, so square root of x squared plus 3. That is g of f of x. Any questions on how I got that? Yeah?
Yeah, how did you use the square root part?
So the square root part, that was given as part of the original function. So if I said to find like g of 2, you would plug 2 in for x. If I said find g of 9, you would plug 9 in for x. If I said find g of x squared plus 3, you plug in x squared plus 3 for x.
Okay.
Sometimes you can simplify, sometimes you can't. You cannot simplify a sum under a root. You could simplify a product, not a sum. Yep.
And so what would the answer look like if g of x was like 9?
If it said to find g of 9, then the answer would just be g of 9. You'd fill in 9 for x. It would just be numeric.
So like g of f of x, if g of x was 9. Does that make sense?
Oh, they always have to give you a variable. Because if g of x was equal to a constant, then there's nowhere to plug anything in. G of x is always 9. So, yeah, you wouldn't have one like that. Yeah. You always have to have a variable in each function to plug into. All right, let's try it the other way. This time it's f of g of x. Okay, Ayla, can you remind me, what is g of x?
G of x is the square root of x.
Yep. So now in function f, everywhere I have a variable, I'm going to plug in this, square root of x. So without simplifying it, can somebody tell me what that would look like? Replace the variable in function f with this expression right here. Quinn?
The square root of x squared plus 3.
Yep, the square root of x squared plus 3, which comes out to x plus 3. But we have to be careful here when we talk about domain and range, because if you look at this final answer, you might think, oh, you can take any number you want and add 3 to it. But if we remember what this came from, there was a restriction originally. When we squared it, that restriction kind of disappeared, right? Because it canceled out. But that doesn't mean it went away when we talk about the domain, right? So that's something we have to be careful about. And I think we're going to do one similar to that in a little bit. Yeah. Okay, so we just have to be careful with domain. It is not all real numbers. Okay, I'll explain to you in a second what it would be. Another symbol you might see for composition is a little circle. And if you have this little circle, it means what's on the right. Okay, I generally don't use that notation, but if you see G, this little circle, and F, it means G composed with F, which is the same as saying G of f of x. All right, so next thing we're going to look at is the domain. Okay, when we compose a new function, how do we find the domain? Okay, and it's actually two steps. Okay, first thing we have to do is look at the inside function. Okay, and we have to eliminate any values that you would not be allowed to use in the inside function. Okay, so what I would do if I was looking at this last problem is I would start with, in this one right here, I would start with f of x, and I would write my domain based on f of x as a starting point. Okay, and when I write the domain, I would eliminate any values that I am not allowed to use in f of x. Okay, after I figured out the domain of the inside function, okay, then what I would do is I would look at my final answer for the composed function, okay, the new one that I created. And I would see, are there any additional values that I need to exclude in the composed function? Okay, I might need to exclude something if the final answer could cause me to divide by 0, or take the square root of a negative. Okay, so start with the inside function. That's going to give us the starting point to figure out the domain, and then go to the composed function and say, is there anything else I need to be careful about? And if there is, take care of that so it's not in the domain. All right, I'm going to scroll back up in a second, and I just want to see, yeah, we've got one with a square and a square root, so we're going to do one just like I showed you earlier. Right, so what I'll do is, just to kind of practice, I'll do a couple that were just numbers, okay, to practice how you would do this numerically. Okay, and the way you do it is you start on the inside when you have a number, and you work your way out. Okay, so the first thing it's asking me to do is find g of 9. So for now, f is on the outside. I'm going to ignore it. Okay, g of 9. So I'm going to look at function g. I'm going to plug in a 9. So that's the square root of 9. And the square root of 9 gives me 3. Now I know what g of 9 is. It's 3. So now I can find f of 3. So that's, let's see, that's going to be 3 plus 1, which gives me 4. Okay, that's how you do composition with a number. Same way you do it with a letter, except you get an answer that's numeric. All right, now let's do it with f of g of x. So what am I finding here? F of what? F of the square root of x. Okay, that's g of x. So now, can anyone tell me the answer when you take and plug in the square root of x into function f? Quinn?
Square root of x plus 1.
Yep. Square root of x plus 1. Any questions on how I got f of g of x? All right, now we're going to find g of f of x. They usually come out different. If they come out the same, that means something. We don't have to be concerned with what that means right now. Okay, but usually they come out different. Right, so how about Rachel? What am I finding this time? I'm finding g of x plus 1. So now, in function g, everywhere I have a variable, I want to replace it with this, x plus 1. Okay, so Alyssa, can you tell me when I replace the letter in function g with x plus 1, what do I get? Yeah, square root of x plus 1. Even though we pronounce it the same way, very different. Square root of x plus 1 on the outside, square root of x plus 1 all under the root. Questions on that? All right. Okay, we'll try one more. This time I want to do the domain as well. So g of f of x, I'll do this one. So that's g of x squared minus 1. Okay, which means I get the square root of x squared minus 1. All right, now the domain. Start with your inside function. Are there any restrictions on the function f of x? Anything I have to be careful with the domain there? Think, Amanda? No? F of x is just x squared minus 1. Okay, that's a polynomial. The domain of any polynomial is all real numbers. So there's nothing to be careful with there. But now we have to look at the final answer. Is there anything I have to be careful with here? Well, Tom, what do you think? There's two things I said you always have to watch out for. Is one of those two things going to happen here? What kind of operation do we have in this composed function? A couple operations, but one I want to focus on.
The difference, subtraction,
Okay, we had subtraction. What other operations are there?
the square root.
The square root. Okay, that's what I'm concerned about. What am I concerned about with that?
Can't do 0. Can't add 0.
You can take the square root of 0. That's okay. But we're on the right track. Amanda?
An x squared and a square root.
That's okay. You can have an x squared and a square root, just as long as something doesn't happen. Casey?
You can't use a negative number.
I would say -2 would be okay to plug in, because I'd have 4 minus 1, and that would give me the square root of 3. Almost what I'm looking for. What don't I want to happen with the radicand? Right. I can plug in negative numbers, but I don't want this answer to come out negative. All right? That's what I don't want to happen. So I want x squared minus 1 to always be greater than or equal to 0. If it's not, I've got a problem. Okay, so I'm going to solve that. Again, x squared is greater than or equal to 1. And now, at this point, I'm trying to think of numbers that I square and they come out bigger than 1. Okay, what numbers can you square and they will come out bigger than 1 or equal?
Anything larger than 1?
Okay, I agree. Anything larger, I would even say equal. Anything greater than or equal to 1, if you square it, it'll come out greater than or equal to 1. Are there any other numbers I can square? Yep, specifically which negatives? Negative 0.5 would not work here. Tom?
Negatives greater than or equal to 1.
Well, greater than or equal to 1 would be positives. So I'm thinking this time we want a less than. Any numbers that are less than or equal to -1. Yep. So the domain is anything from negative infinity up to and including -1. Or you can pick any number from 1 to infinity. In other words, do not pick a number between -1 and 1. It won't work. Okay, and we could type that in and you could verify that. So you're going to have a gap on the screen between -1 and 1. There'll be nothing there. Let's just take a look. Square root of x squared minus 1. So you're going to get this kind of shape that goes in each direction. With this gap in the middle. Okay, any questions on that? While we're looking at it, what would the range be for that? Thoughts on the range? The range of the y values. X is what you plug in. The y values are the answers you're going to get out. How high and low does the graph go?
Brackets 0, infinity.
Yep, I'd argue that's going to go from 0 to infinity. And we know it's going to hit 0 because if you plug in 1 for x, which is in the domain, you get 0. Right? So that range would be from 0 to infinity, bracket, just like Quinn said. All right, and looking at it the other way, f of g of x. Right, I'll do that part. So f of square root of x, which means I'm going to look at function f, and everywhere I have a variable, I'm going to plug in square root of x. So it's, let's see, the square root of x squared minus 1. We had one like this earlier. It simplifies. Square root and square cancel. And we get x minus 1. Okay, now to find my domain, start with the inside function. Are there any restrictions on g of x in this problem? How about that, Andrew? Any restrictions on g of x?
Can't be negative.
Okay, I agree. Can't be negative. So can you tell me what numbers would I be allowed to use?
0 to infinity.
Yes, 0 to infinity, including 0?
Yeah.
All right, so let's just keep that in mind. 0 to infinity. I'm going to write it off to the side. Now look at my final answer, x minus 1. Is there any number that you're not allowed to subtract 1 from? What do you think, Trevor? No, you can subtract 1 from anything. So this time there's no additional restrictions from the final answer. The restriction actually comes from the original composed function, which you'd never be able to tell looking at the final answer. So the domain here is only numbers from 0 to infinity. And I'm going to show you how you could graph that on the calculator. Okay, let's type in square root of x. Okay, for, oops. Let's get that. Type in second square root of x. And now I'm going to type in x squared minus 1, but I'm not going to type it in. I'm not going to type it in the way that it's written here. Okay, I'm going to show you how I can do this on the calculator. I'm going to go and press variables, y variables, function, and I'm going to take y1 and I'm going to square it. Okay, so what that's going to do is it's going to remember that the square root of x was there originally. It's not just writing x squared. The calculator is going to remember that whatever I get for a final answer, the square root of x was originally part of it. All right, so I'm going to type that in. And what else is it? So it's the square root of y1 squared minus 1. Second square root. And I'm having a little difficulty with the square root. Let's try again. Second, insert, second, square root. No, not what I want. I'll just type it again. Variables, function, y1 squared. That's what I want. So it's the square root of y1 squared minus 1. And get rid of that and that. Okay, so now when I graph it, it's going to take y1, square root of x, it's going to square it. So I'm going to get x minus 1 under the square root, but watch how it graphs it. I wanted to turn those other two off. I just want you to look at the final graph that's going to come up. Okay, so ignore this one. Okay, just look at the final graph. All right, so let's see. That should look like x minus 1. Which should be a line with a slope of 1 and a y-intercept at negative 1. Why doesn't that look? Let me make sure I typed it in right. Oh, this one doesn't have a square root in it. It's just x squared minus 1. It's not the square root of x squared minus 1. So after all that work, I don't even need the square root here. It should just be that. All right. So the square root is only on g of x. Perfect. Now when I graph it, it looks like a line with a slope of 1 and a y-intercept at negative 1. But notice it's not going past 0, because that was a restriction on the domain. If you say, you know what, I'm just going to type in my answer the way it looks on here. I'm just going to type in x minus 1. Well, now it's not going to have that restriction because the calculator has no idea that you had a square root originally. It's just graphing x minus 1. Okay, so you can graph composed functions, but it's a little tricky, and you don't have to worry about that too much. Okay, just know how to find the domain. All right, and the last thing we'll look at with a composed function is how we find the range. Well, in order to find the range, first of all, you need to know the domain. Okay, so start with that. And then this is the part where I think the graphing calculator helps us out. You have to figure out, once I know my domain and I plug those values in for x, what kind of answers am I going to get for y? That's my range. Okay, so determine what values are going to result for y when you plug the domain in. Sometimes it's not too bad to figure out with that problem we did with like absolute value of x divided by x. There was only 2 numbers in the range, and we could do it without a calculator. But usually the range is a little tricky, so I usually graph it, and then I look at the calculator. All right, I'm not going to do both this time. Let's just pick one. Do you want to do just the first one or just the second one? Just the first one. Okay, so we're just going to find g of f of x, and we'll do the domain and the range. Does everybody have the 2 steps to find the range? Okay. All right, so I'm going to find g of f of x. Okay, f of x is the square root of x. So in function g, replace x with the square root of 3. I'm sorry, in function g, replace x with the square root of x. And then the final answer is square root of x minus 3. Domain. What is the restriction on the inside function? Square root of x. What kind of numbers do I have to pick, Molly?
Either 0 or above.
Okay, so on the inside function, I have to pick numbers that are 0 and above. How about on the composed function? What kind of numbers do I have to pick there? Yeah? You could pick like 2 would work. You could do the square root of 2 and then subtract 3 from it. Because that 3 is not under the root. It's outside of it. If we did it the other way, it would be under. So what kind of numbers do I have to pick for this part? Yeah, Amanda?
Is it the same as the original?
It's the same as the original. So there's a restriction on the inside, which was 0 and above. On the composed function, it's still 0 and above. So we write the domain is 0 and up. Now the range is if we take numbers 0 and up and plug them in for x, what do we get for y? All right, let's try plugging in 0. Jeff, what's the square root of 0? 0. And what take away 3? Negative 3. Plugging in 0 for this first part and then subtracting 3 shows you the lowest value you'll ever get. So it's negative 3. And now, is there an upper limit on this? Like if I plug in square root of 10 and then subtract 3. Square root of 100 and subtract 3. It's just going to keep going up. Square root of 1,000,000, subtract 3. So there's no upper limit on the range. So if you wanted, you could graph that. But it's basically going to look something like this. It's going to be a square root function starting right here, curving up, never leveling off, going up very slow. Any questions on my domain or my range? All right. Okay, so that's basically how you do a composed function and then how we work with domain and range. Okay, next thing we're going to look at is how we can do a transformation, okay, kind of like we did yesterday, but we can write the answer as a composition. Okay, so this can be a little tricky. So this time, what they're doing is they're kind of giving you that final answer. Okay, they're telling you the answer to the composed function. They're giving you one of the functions. They want you to find the other function that would generate the composed function. All right, so a little harder, and sometimes there's multiple answers. Okay, but we try to think of the simplest one we can. All right, so I know f of x equals x squared. I know g of f of x equals ax squared. Okay, this would be like a vertical stretch. I want you to tell me g of x. All right, so let's just plug in what we know. We know f of x is x squared. So can anybody think, looking at this, what would function g have to be so that I would plug in this and get that as the answer? It's a little tricky to think about, but you got to have a letter in it somewhere, and there's got to be an A somewhere because that's popping up in the final answer. Yep, Quinn?
Just
If you just had an A, you wouldn't have anything to plug in. Because remember, this is a function in terms of x, so there's got to be an x here somewhere. So we have something to plug into. Yeah?
AX.
Yeah, ax. Okay, let's try it. So now, in function g, replace the variable with x squared and see if you get that. Okay, do we? In function g, replace the variable with x squared, and we would get ax squared. Yes, that's the answer. All right, let's try this one. So again, f of x is still x squared. So g of f of x has to equal x squared plus k. So somehow I need a function g, so that when I replace the variable in function g with x squared, I get the answer x squared plus k. Ma'am?
Is it X?
Yeah, x plus k. Let's check it. Replace in function g, every time you see a letter, replace it with x squared and see if you get that. Replace x with x squared, I get x squared plus k. Perfect. Yeah. Any questions on that one? All right, so it's a little tricky. Okay, I'm not going to graph this because we already graphed it yesterday. But we saw when you replace x with negative x, it's a reflection over the y-axis. So if I did that, I would have this. Okay, if you graph what's on top and what's on the bottom, I just want you to understand these are reflections over the y-axis. Versus, what if I did this? I'm going to put it off to the side. You don't have to write this down. How would this look? What would negative f of x be? Oh, Gracie? Sure. Anyone help her? Quinn?
would be a negative parentheses x plus 3 x squared.
Yeah. So this just means to take f of x and take the opposite of it. Basically stick a negative in front. And do you remember what this would do? This is not a reflection over the y-axis. That's a reflection over the x-axis. Okay, again, you don't have to write that down. I just want to make sure we remember the difference between reflecting over x and y, and I'm going to summarize it in a second. So go ahead, if you want to graph that, you can try it on your calculator sometime. It's a reflection over the y-axis. Okay. In fact, all the transformations we learned yesterday, they don't just apply to parabolas, but they apply to any function you want to talk about, whether it's a trig function, square roots, logarithms, exponentials, it doesn't matter. Transformations work the same every time. Okay, so I'm going to show you a list of functions. I'm going to describe a transformation, and then the formula of what it would look like. Right, so if you take a function and you put a number in front of it, okay, like 3x squared instead of x squared, that's always a vertical stretch or shrink. And it doesn't matter if it's a parabola. It could be this versus this. That's your basic square root function. That's a square root function with some kind of vertical stretch or compression. In this case, a stretch. How about when we shift a function up or down? How do you shift up or down? You don't multiply by a number in front. Anyone remember what we do for shifting up and down? Yep.
You add or subtract the number after.
Yeah, you add or subtract a number outside the function. So we had an example yesterday like x squared plus 3. That's a vertical shift up 3. How about if I want to shift something left? How do we take a function and shift it left? Yep.
Would you add something on the inside of parentheses?
Right, we're going to add something, but this time it has to be inside parentheses. And if we wanted to shift right, we would subtract something. But it has to be inside the parentheses. Okay, how would we reflect something over the x-axis? Okay, we know we have to put a negative, but where do we put it? Inside the function or outside the function? So it's the difference between doing something like this versus this. Yeah, Amanda?
X on one side.
Yep. When you're reflecting over the x-axis, the negative is out in front. And when you reflect over the y-axis, that's when you put on the inside. Okay, any questions on those? Just kind of generalizing everything we did yesterday to any function. All right, so I'm going to have you try to do some of these functions, but I'm not going to give you a formula. Okay? All I'm going to give you is this picture. Okay? And I'm going to call this picture f of x. Okay? This is the graph of f of x. And I want you to do that to it. Okay? What is it asking me to do? If that's my basic function. Can anyone describe the transformations that I'm doing to it? Yep.
Vertically going down 3.
All right. What's the first one we're going to do?
There's a.
I do agree. We're going to shift it down 3.
That's the second one. And the other one is horizontally left 2, right? Or no. Horizontally left 1.
It's going to go left 1.
Associated first.
Okay.
That's the one I'm looking for. And then we'll talk about what this 2 is going to do. All right. So let me
No, that's the first one.
sketch it one step at a time. Step 1, shift everything left 1 unit. Okay, so I'm going to be, and you can really just watch this. Here, here, and then 1, 2, 3 units. All right, so that's step 1. Okay, and what I'll do is put step 1 in black. Okay, step 2, what am I doing?
You're gonna stretch it vertically.
Yep, I'm going to stretch all the y values. All the y values are going to be doubled. Keep all the x values the same. Stretch the y values. So what do I get if I doubled this y value? What's it at now? And then double it. Still 0. This one is still 0. How about this one? It's going to go to 4. Okay, so that's our vertical stretch. And lastly, my third step is to take that graph and do what with it? Move everything down 3. So 1, 2, 3. 1, 2, 3. And I'll erase the other one so you just see the final answer in a second. 1, 2, 3. Okay, so this is one that really tests if you know how to do the transformations because you don't have a formula. Okay, you can't plug stuff in, you just have to do it visually. Okay, and that's how I do it. Just do it one step at a time. Okay, any questions on that? And then the third one is right there. All right, so this will be our last one for today. Okay, so it says we are inflating a spherical balloon, and the radius is changing at a constant rate of 2 inches per second. Okay, so as we're blowing this balloon up, it's increasing at a constant rate of 2 inches per second. If we had a variable rate, this would become like a calculus problem. It would be a little more challenging. Okay, but we're going to assume that it keeps blowing up at the same rate. We're going to assume, even though this is a little unrealistic, but before we start blowing it up, the radius is 0. Okay, it's not even a sphere yet. It's just an uninflated balloon. Okay, what I want is an algebraic representation of the volume of the balloon as a function of the time. Because the volume isn't the same. The volume is constantly changing. So I want volume as a function of time. And then once we have that formula, I want to know the volume of the balloon after 5 seconds. Okay? I'm not really as interested in the second part. I'm more interested in the first part. So what do you think something we're definitely going to need to know here is? What formula do you think we're going to have to start out with? Yeah, Josh?
Formula of a sphere.
Yeah, we need the formula for what about a sphere?
The volume of a sphere.
Volume. Does anybody know the formula for the volume of a sphere? Four-thirds, yeah. That's good. That's usually the part people don't remember. 4/3. There's pi in there because anything with circles has pi.
Pi r
Cubed.
It's 4/3 pi r cubed.
Yes.
Francisco!
Actually used it.
Okay, so that's the formula for your volume as a function of the radius. Okay, 4/3 pi r cubed. Okay, questions on that part? Okay, if you didn't know that, that's something I would give you. I wouldn't expect you to have that memorized, but if you do, that's good. All right, now let's find a formula for our radius as a function of time. Right? Can somebody give me a formula for my radius as a function of time? So in other words, you tell me a time, plug it into this formula, and it'll tell you what the radius of the balloon is at that time. Well, let's think about at 0 seconds. What's the radius of the balloon at 0 seconds?
0.
Yeah, it doesn't tell us much. How about at 1 second? 2. And then 2 seconds? 4. So now if you really had to, you could take these 2 points and find the equation of the line. But does anybody see, when you see your y-intercept, what's your slope here? 2. Your slope is your rate of change. That's what slope always is. So what's the equation here that gives me my radius as a function of time? Yep, Josh.
2x.
Yep, 2, just what letter are we using here?
T.
T for time. Okay, there's your formula for radius as a function of time. Now we need to combine these two. How do you think I'm going to combine them? What operation we learned today do you think I'm going to use? Yeah, I'm going to compose them. Okay, what I'm going to do is I'm going to find V of R of t. Okay, and what that's going to do is it's going to replace all my r's with t's. So I want the volume as a function of time. So take 4/3, pi, and now everywhere you have an r, replace r with 2t. Okay, so now what you have is volume as a function of t, time. What's 2t cubed simplify to? So you cube the 2. 8. Cube the t. T cubed. Okay, so really the simplest way you could write this would be, think of all these as fractions. 4 times pi times 8 is 32 pi t cubed over 3. Plug in your time, and this formula will generate the volume of the balloon at that time. Okay, so if you want to know it for 5 seconds, just fill 5 in for t. All right, so for tonight, okay, I'd like you to try it on page 66. Okay, 1 through 3. 6, 8, 13 through 15. Okay, 22 to 25. And then 32, 40, 44, 57, 63. Okay, so we'll look at that tomorrow, and then tomorrow we will start chapter 2, and that'll be our last section before the test. Okay, tomorrow I'll also talk a little bit about the test, what's going to be on it, and review sheet and stuff like that.